Hi, my name is Caitlin Beavers, and I'm fixing to do the periodicity and the periodic table lab. And I have a helper with me. She's on the other side of the camera, but you can't see her. Hi! Okay, activity 1. Examine all the cards in deck 1 and note the various characteristics of the cards. Okay? They're all colorful. And they have like shapes and numbers on them. Sweet. Choose one characteristic and arrange the cards according to the chosen characteristic. This may involve grouping or ordering depending on the characteristic chosen. Could do it based on number, I guess.
Well, there's a lot of characteristics.
I know.
It's not very specific.
I know.
They're all cardboard. And that
Right.
number is weird. Why is that one different?
Like, it's larger and then smaller, but I could just do it all based on number, I guess.
Or size of number, or color of card, or shape of...
I mean, there's a million different things, so I'm just going to do number, whatever. So 1, 3s, 9, 7, 5. Oops. Lexi, stop growling over there.
We have a second lab assistant.
Oh, they're all odd numbers. I just realized that. Okay. 1, 3, 5, 7, and 9.
Go fish.
Okay. Where'd my pencil go? I had a pencil somewhere. Here it is. So, we redid it in numerics. Okay, put the cards back into the pot. Okay. Got it. And, moving on. Choose another characteristic of the cards and arrange the cards according to the chosen characteristic.
Were you supposed to document what cards were in each of your chosen characteristics?
No, I just had to say how I characterize them. Whatever. So I guess I'll do color this time.
There's going to be one of every color.
Wait, what?
There's going to be one number of every color.
Yeah, and big numbers and small numbers.
What is the correlation? We shall see.
No idea.
These mind trickery games.
And color. 1, 3, 5, 7, 9. And here it's blue, yellow, green, purple, pink. Okay. Arrange the cards in a way that incorporates both characteristics listed in the observation section. Okay, so I have to do it by color and number?
I guess.
How did that happen?
Magic!
Seriously, what the heck? This is getting interesting.
Are we counting cards?
Here's all of my 7s and all of my 5s. I'm like freaked out right now. What the heck? Oh, well, that one didn't work out.
No.
Darn.
Shoot.
It's getting interesting for a second. And then 3s. Ooh, I'm running out of space. Okay. Get down, baby. I can't hold you right now. Okay. Observe any trends or patterns associated with the way the cards are organized. They're in increasing order and also by color.
Wait, please restate the question.
Observe any trends or patterns associated with the way the cards are organized. They're organized by color and by number.
Yeah.
So they're organized in...
And there's no repeating colors or numbers.
Yeah.
There's a word for that, but I don't remember what it is. Don't take me back to statistics.
I'm afraid. Okay. So photograph the arrangement of card set 1 as a record of your work. Without distributing the arrangement, remove 2 cards at random. I'm going to take a picture first.
Would you like to pan the camera on it?
Is there anything that's like the same? No, I need to take a picture of it. No, actually, like the video. Look, they get smaller to bigger as well, the shapes.
Yeah. The shapes are larger, but the larger the number. And look at the size of the numbers too. The numbers on the purple cards are the biggest.
Oh, all bigger.
And then the yellow, and then
bigger.
the green, and then the blue, and then the pink.
Oh, yeah. Interesting. Okay. So, I need another piece of paper. Can you grab me a piece of paper?
Please break while we get paper for the lab.
Pause.
I'm such a good assistant.
So what number is this? Number 8. So, larger number equals larger shape.
Do you mean physically larger number or larger?
No, larger number. As
you need to specify.
I do. How do I specify that?
Numerically larger number and physically larger number.
I guess.
An integer, the number integer is larger.
Numerically. Okay. And then physically larger number on yellow and purple.
The purple is the largest, followed by the second largest of the yellow, then the third largest of the green.
Are they even bigger?
Yeah.
Oh, they're all different sizes.
Yes.
I thought they were all the...
No, they're all different sizes. So purple, then yellow, then green, then blue, then pink.
Yeah. On yellow. And decreasing in size in this green, blue. Okay. Is there anything specific that we noticed about the shapes? That's one thing that we have. I haven't really noticed a correlation between. All the shapes are kind of just.
Well, the shapes
random.
are smaller on the ones than on the.
Yeah, we said
nines.
that. But anything particular, like all the pink cards aren't the same shape or anything like that. I think that's it.
All of the 3s have different shapes. All of the 5s have different shapes.
I mean, all of them have different shapes.
No. That's a triangle, that's a triangle, that's a triangle. That's a diamond.
No, I'm saying all the ones have different shapes. All the 3s have different shapes. All the 5s have different shapes.
Correct. That's what I'm saying.
Okay.
Yeah, they don't have the same number of sides or anything, so it's not like that.
Next step. Okay, photograph, and then without disturbing the arrangement, remove 2 cards at random. Place these 2 cards aside. Okay. And photograph the arrangement of card set 1, showing blank space for the missing cards. Lexi. Okay, and then we have to share. I'll have to share with somebody. I'll have to find one of my classmates. And then photograph the 2 cards set aside in step 10. Share the photograph with a classmate according to instructions. And gather cards for deck 1 and put them away. So these are the 2 that I set aside. And obtain and open the photograph showing the same classmates' missing cards or the features from the missing cards. Okay, so I can't really finish this one. Okay, moving on to activity 2. Lexi, you're okay, honey. Okay, examine all the cards in card deck 2. And become familiar with their similarities and differences. Okay.
Repeating the initial process from card deck 1 for card deck 2.
Okay, so they all have atomic mass, atomic radius, ionization energy, oxidation, valence electrons, and the formula. And not all of them have a formula. Some of them say none. But otherwise, they're the same. Okay, yeah, they're all the same except for some of them don't have a formula.
They're all the same except for the differences.
I mean, they're all white. They're all the same size. Don't know. Anyway. Okay, remove the card with atomic mass 1 and the card with atomic mass 4 and set them inside until step 8. Well, that's going to take a minute to find. Atomic mass 4? Is that what it says?
Mm-hmm. 4 and 8.
Atomic mass 1 and 4.
Oh. Pardon my.
Mm-hmm. Trying to mess me up.
She passed the first hiccup.
Who? What? Oh, me? 1. Okay. I'm going to set them aside until step 8. Okay, choose one property on the cards that would allow cards to be placed into groups. Record this property. One's with formulas and one without formulas. Formula, not formula. Formula, not. All of these have oxygen with them.
O2?
No, just the oxygen molecules. It's an X, whatever that element is, combined with an oxygen. Oh, it says formula with O. That makes sense, wouldn't it, Caitlin? Oh, goodness. Okay. So... So, with formula and, let's say without formula. Stack cards into groups using the property recorded in the previous step. Choose another property on the cards that would allow cards to be ordered within each deck. Let's see. Guess I could do it by valence electrons. So 6, 1, 2, need to do this in a better way. So 8, 6, 1, 2, 3, 4, 5. Oh wait, I'm looking at the wrong number. Shoot. Hang on. Pause. 7 and 7 and 7. Those all go together. 8.
She was indicating a figurative pause, not a literal pause.
6, 3, 3, 3, and 3. 6, 2, 2, and 2. 5, 2, 5. 4, 4, 4. Yeah. 5, 1, 6. Okay, so I did it by valence electrons. Spread each stack of element cards out into in order to call them using the property recorded. To do that, observe any trends or patterns associated with the cards are organized.
No, they want you to put them in columns and like everything like you did with the first set. So you can see all of the features on it.
Oh, I just have to do it this way. So, ones. It doesn't have to be columns, it could be rows.
It's columns.
Whatever. What are these? Oh, I set those aside. Okay. 1.
Broken.
Yeah. I'm still running out of space, dang it. Nativity scene. You're going to just have to move out of the way, honey bun.
Kind of, I was thinking.
Babe Jesus, that's to move. Okay. Okay, so now that I spread them out in columns, observe any trends or patterns. So, oh my goodness gracious. Lexi Lou.
Why you listen?
Okay, so all of my atomic masses are increasing in order. My ionization energy increases from left to right and from bottom to top like it's supposed to. And no.
Puppy and
what is that? Number 7. Okay, what else do I see? The atomic radius. Mm. Decreases from right to left. And from decreases from bottom to top. What else we got? Oxidation state correlates with each column. Oh, the oxygen has a thing too. Each column has a certain number of oxygen atoms combined with the X atom. See. And then the last set don't have any. Okay, I think that is it. Moving on. Pick up the 2 cards set aside earlier and incorporate these 2 cards into the arrangement using the patterns or trends observed in the previous step. So this one is a 1, and this one is a 2. So my atomic mass still increases, my radius still decreases, my ionization energy still, let's see. It increases except for the noble gases with the valence electrons of 8, which is the same. I think this one goes over here better than there, because it's like the noble gases. Atomic mass 1 fits into column 1, and then atomic mass 4 fits into 8. And they have the same observations as above. Okay. And then photograph the arrangement of card set 2. That's done. Without disturbing the arrangement, remove 2 cards at random. Place 2 cards. Photograph the arrangement. Share the photograph with a classmate. Photograph the 2 cards. Set aside. Put them away. Okie doke. And then photograph my missing cards.
Leaving a thing
Mm-hmm.
on FedEx. They delivered a picnic hippo to a zoo in Oklahoma.
Mm-hmm.
It was about this story. Then I proceeded to read all of the comments, or a lot of the comments, and it was just people complaining about their packages had been lost.
Oh my gosh.
And it was like, this beautiful pygmy hippo
Right.
that made it to the zoo just fine. And someone said, I'm so glad you didn't lose her like
Lose
all my packages.
That's hilarious.
And someone was like, oh dear Tom, this is Rebecca, do you need assistance? On behalf of FedEx.
Oh gosh.
No.
Okay. Moving on to activity 3. Oh my goodness gracious. This is riveting, isn't it?
No, someone asked how much it cost to overnight the hippo, and FedEx responded with, please use this link to get rates to change the time. What a legitimate response.
Oh my gosh. That's hilarious. Oh, the things people say. Okay. Examine cards in card deck 3. Okay. Okay, we have the actual names of the elements, the element symbol, atomic number, mass, radius, and it has all the information that the other ones just had, and it has the noble gas electron configuration. So, sweet. Moving on. Remove the hydrogen and helium. Alexis London, you need to chill. You do. Helium. Hydrogen.
Now there's always comments about hippos, and someone was like, I don't have the dimensions of my hippo. And they're like, well then you obviously don't have a hippo to mail. If you had one, you should have its dimensions. I was like, well, they should be able to give me an approximate shipping cost as they just shipped one.
Mm-hmm. That's true. Oh my gosh. Okay. Did that. Stack the cards into 8 groups on the basis of their number of valence electrons. That's what I just did with the other one. Look at that. I'm so smart. Okay. 4.
And then someone said, I only want hippopotamus for Christmas. Only a hippopotamus will do.
Oh my gosh. Okay. Then, place the text in an ordered row so that the elements with 1 valence electron are to the left and the elements with 8 valence electrons are to the right. So that would be in a column, but you know, whatever. This is literally what I just did with the other cards.
Yeah.
Okay. I'm making a periodic table if you would like to come watch me.
I'm reading about Francesca in the bottom.
This is literally, they're not exactly in the right order, but it's going to look like a periodic table, is the whole point. Kind of. You're missing all of the metals that are in between there, but you know.
I don't know where they live on the table anyway.
They're in the middle.
That's why I'm a marketing student. Arsenic is bad. You know that.
I'm sure a lot of these things could be bad in the correct circumstances.
Sure, certainly. Selenium can be bad. These are only like vitamins or things that you take. Chlorine goes in your pool. Iodine.
The double gases, because they got 8 things left.
Krypton. Is that what killed Superman?
I have no
No,
idea.
it's kryptonite.
Something. Okay. Now they are in rows. Wait a second. Please. Oh, jeez. Within each of the stacks, arrange the cards from the lowest atomic number to the highest atomic number. I should have read that step before I did all that. Atomic 3. Boom. 3. 8, 5. 16, 7, 15, 18, oops. Okay. And then, okay, spread each stack of element cards out into an ordered column so that the card with the lowest atomic number is at the top of the column. There should be 4 rows and 8 columns. 1, 2, 3, 4, and 8 columns. Yes, that's what I did. Okay. Pick up the 2 cards set aside earlier and place hydrogen card above the lithium card on the top left. Ta-da! And then place the helium card above beryllium. What? Oh. That's bromine.
Oh, I can't read upside down.
On the top left. Determine which helium card properties matches those of other cards in this vertical column. Record the similarities and observations. And then move the helium card over to the neon card and see what matches there. Observe any trends or patterns associated with the cards. And photograph the cards. Okay. So I'm going to take a picture of them first.
We have to do like a wide.
Yeah, earlier I did like half and half. My computer's in the way.
No, you can't probably see anything with the camera.
Probably not, but whatever. You can hear us.
You can hear Lexi. She's consistent in all of your labs.
She is very consistent in all of them.
Me? No.
Okay. Where are these? So, what is similar in all of this? Kind of the same things as in the last one. So they increased by atomic number in order. And then I'll have a few extra things. So my radius decreases from right to left. Yep. And then my oxidation state correlates with each column. So positive 2, 3, 3, 2, 1, 0. Yep. And then each column has a certain number. Well, that's different because one of that's still there. So really the only thing I need to look at the atomic mass increases in, where's my mass? Oh yeah. So atomic mass increases in order, right?
Mm-hmm.
Okay. Actually, I need to answer the questions about helium first. That's not it. This is it. So above beryllium, what's common? So they have the same number of valence electrons. And that's about it. You see anything else? I don't see anything else.
Well, I'm trying to read upside down, so it's not really very helpful.
Yeah, they have the same number of valence electrons.
Yeah.
That's really it. Oh, so number.
And they both have the letter I.
And then when I put it over here.
What's the point in moving it? Because sometimes it can be one of those.
Yeah, so helium, is like at the top, so it's hydrogen and helium. But helium can only have 2 valence electrons, where all the other ones on this side are noble gases and they have 8 valence electrons. And then their ionization energies are extremely high because they have the number of electrons that they want and they don't want to change. So the ionization energy is high. So to take away an electron is your ionization energy, basically.
Don't tell Ms. Knowles I don't remember this. It's been 7 years.
Lexi, would you please stop growling? The atomic radius is larger. It fits in with that one better.
You know what makes my radius larger? Pi.
Okay.
Pi r squared, cake r round.
Lexi, do you need to go outside?
Ball?
Larger. She doesn't know what a ball is.
Only her sister knows.
Yeah.
I tried.
Oh, I didn't look at it. It doesn't have any electronegativity. And then 9, 10. And then now I'm just going to observe regular trends.
I forgot to tell you my new job. They have chili cook-off.
Oh, fun. Increase in order. And And then my ionization energy is the same except for the noble gases. Okay. Then the oxidation state still correlates. And then each column, yeah. And they all have the noble gas electron configuration. Ick-a-doke. I think that is it. I don't really notice anything else. I already took a picture of them, so now I just need to collect them in increasing atomic number.
He won't stop messaging me.
I'm sorry. Stop messaging them back.
I'm literally not even messaging him back.
Lexi, stop, baby.
He's like 2.5 years back on my Instagram and keeps.
So those are in order.
Lexi.
Well then. This looks short. Use the data from card deck 3 to prepare a visual representation, a graph or an illustration or model depicting period trends for each of the following. Submit electronic files or photographs of representations prepared during this activity according to your instructor's directions. To create using chemistry textbook or other research ideas. Okay, well, I'm gonna have to do that on the computer, so I guess that's the end of my video.
Bye, video.
Bye, video. This was fun.